Guys, we're gonna begin shortly. I'm just organizing the summary notes on matrices because a lot of persons would have identified matrices as a weaker area. So just give me 2 more minutes and then we're gonna begin, okay? So just be ready. We're not gonna do any real calculations. I'm just gonna go over everything on the matrices, especially matrix transformation based on the note I would have sent a picture of. So we're gonna look at that tonight. Okay. So just confirm that you're hearing me, and I am going to share my screen in about 2 minutes. Make sure you get some water. Make sure you're not comfortable because I don't want this to be strenuous for you. I want it to be useful and help you to remember stuff. All right. So give me 2 minutes and then we're gonna jump into it. Awesome. So what we're gonna do, we're gonna cruise through everything that possibly could come on matrices and matrix and do some refreshers, okay? So I hope you guys are ready. So let's get into it. So the first thing we need to remember is what the order of any matrix is. We know it's M times N, and the first number always represents rows. The second number always represents columns. And we should remember what rows is. Rows is going across, columns is going up and down, right? So if we were to look at this given matrix, what is the order of this given matrix? 2 rows, so that's 2 times 3 columns, so that's 2 by 3, right? So when we look at all of this, we should be able to remember these stuff. Now, a matrix is called a square matrix if the number of columns and the number of rows are the same. So this is a 2 by 2, so that's a square matrix. 3 by 3 would be a square matrix as well. 4 by 4, etc. Then we have our null matrix or zero matrix where all of the elements are 0. Then we have the identity matrix. We need to remember this. This is very important. If at any point, guys, y'all need me to stop and pause or to repeat or to explain further, let me know. Because remember, this is just a quick recap on the topic, okay? If you need me to stop for a minute and touch upon something, that's perfectly fine. So as I was saying, the identity matrix is very important. It plays a huge role in matrix, so you have to remember it. That's 1, 0, 0, 1. That means if you multiply any matrix by I, when you multiply it out, you can get back the same matrix A. Everybody see that? So essentially, I is the same thing as 1 in our regular number system. Okay? Next, we have equal matrices. And so if we say A and B are equal, what does that mean? If we look closer, you realize that these elements must be the same. A must be equal to E, B must be equal to F, C must equal to G, D must equal to H. This is important because sometimes it is asked you to prove or find missing elements from equal matrices. I think there's supposed to be one coming up. So for example, look at this. If they were to ask you to find X, isn't it obvious what X is? X is completely equal to -2. And if you look at 2y, 2y is equal to 6. So what would be the value of y? If 2y is equal to 6, what do we do to find the answer? We transpose. And I want y'all to remember algebra is a part of finding out missing information in every topic. You're going to always have to transpose. So use your basic algebra skills to figure that out. So everybody just confirm if you understand this concept. This comes a lot, especially in paper 1. So if you're good to go, just say good to go. Yeah, got it or good to go. So I see one person. Let me just take an opportunity to see who's all here. All right. Kayla, what you said, not really? If each element that holds the same position are equal, so look at it. X is equal to -2 because that's the first element A. -3 and -3 already match. 5 and 5 already match. But what did they say? 2y, because they are equal, these two gonna be equal to each other. So if 2y is equal to 6, you don't understand how to find y? When all you're really required to do is transpose. You get rid of the 2, what is left back? So 6 divided by 2 is 3. This is nothing to get flustered about because it's just really algebra. The only concept you need to remember is that in an equal matrix, the elements of both sides are the same. So whether they represent it using a single letter in this case like this, or if they use a compound term like that, okay, it's just solving. Moving along, the addition rule and subtraction rule. What do we know about the addition and subtraction rule? You could only add and subtract two matrices that have the same order. So I could only add a 2 by 2 to a 2 by 2. Why is this important? When you're adding matrices, you only add in the elements in the same position. So I would add the A to the A, the B to the B, the C to the C, and the D to the D. Okay, quick revision. Another thing, what did we learn here? What do we assume based on this answer here? Would these two have the same answers? Would A plus B and B plus A have the same answers? That's a question for everybody. Yes. Why yes? Because what's the rule that tells us it will be? And these are things you need to remember. What's the rule that tells us that A plus B is equal to B plus A? The commutative law. Excellent. Now, let me ask this question. Will B minus A be the same thing as A minus B? No, because subtraction does not obey the commutative law. The only options that obey is addition and in some cases multiplication, but you still gotta be careful. All right, so look at it. Addition of matrix is commutative. So that's something straightforward. Subtraction is not commutative. Yes, I can post it after. No, we have scalar multiplication. Scalar multiplication is when we use a number to multiply the bracket. So if we look here, if we have A and I ask you to find 2A, what does that mean? What does 2A mean? 2A means 2 times A. That means all of the elements in A we have to multiply by 2. So quick revision, 2, -3, 4, 1. What is this equal to? This is going to be equal to 2 times 2, 2 times -3, 2 times 4, 2 times 1. And everybody should know how to multiply that out. Same thing happens when you use a fraction. If I tell you find a half of A, what do? So you find a half of A. So it's going to be half of 2, -3, 4, 1. Each number would be, what's going to happen to each number? You're going to divide each number by 2, because we know multiplying by a half is the same thing as dividing by 2. So what we're going to end up with, 2 over 2, -3 over 2, 4 over 2, 1 over 2. And so we simplify it. We're going to end up with 1 because 2 over 2 is a whole. We leave this as a fraction because it can't be simplified further. 4 divided by 2 is 2.5. If you let confirmation, everybody, if you're with me, talk to me. All of this is revision. If these things come, we should be able to mash it up. You know what I need to find? I need to find the list of topics that come in for exams again. All right. So here, if they ask you to find 2A minus B, you should know what to do. You multiply 2A by 2, and then you subtract B. And we already discussed how to add and subtract matrices. So anything of this nature, if it comes, you should be able to handle that. All right, next one. When we look at anything when it comes to multiplying, we should know how to multiply, right? And just to be certain that we understand, if I have a matrix, let's say 3, 1, 4, 2 times, let's say 2, 5, 6, 1. Can these two be multiplied? Yes or no? Everybody, can these two matrices be multiplied? Because to be honest, those are the types of questions I'm going to be asking. I'm going to be asking you rules to see if you remember the rules, because those are the most important stuff. How do we know if two matrices could be multiplied? First of all, you identify the order of both. So the order of this one is 2 by 2. The order of this one is 2 by 2. In order for a matrix to be multiplied, the two inner numbers must match. Everybody remember that? So let me use a different color so it stands out. These two inner numbers must match. What do they represent? This number represents the column of the first matrix, and this number represents the row of the second matrix. So essentially, what's the rule? The rule for two matrices to be multiplied is that the column of the first matrix and the row of the second matrix must be the same. Everybody remember that? And from this, we could also determine the answer of our matrix. What is the order of the answer? It will be our outside numbers. So these two numbers going to tell me that my answer is going to be a 2 by 2. So these are the things we need to remember. Once the inner numbers match, you can multiply, and the outer numbers will give you the order of your answer. You know how we work it out. We map out our answer. And when I say map out, you draw your lines to represent your two rows and your two columns. And then what do we do next? We identify our rows. Please do not take these things for granted. Circle your rows. Circle your columns. And so we should remember how to multiply. Should I multiply it out just to make sure we remember? Yeah? All right, so there we go. Rows by columns. So we're going to go, remember we got different positions. There you got top left, top right, bottom left, bottom right. So that's kind of how you keep track. So let's go. We're going to do top left first. So this is top, this is left. So we're going 3 times 2. You write it out. 3 times 2 plus 1 times 6. 1 times 6. Let's do top right. So I'm going to use the top row, right column. So that's 3 times 5 plus, use the second element now, 1 times 5. 1 times 1, sorry. Everybody with me? Let me know, please. Let's do the bottom now. Let's do the bottom left. So that would be 4 times 2 plus 2 times 6. Bottom right. So that would be bottom right. 4 times 5 plus 2 times 1. Anybody remember how to make sure you answer right? Which numbers should be matching? This should match. This should match. This should match. This should match. You don't ever start multiplying and adding unless you confirm that they're matching. Okay, so now that I have identified that I am correct and confident, I do my multiplying and addition. So 3 times 2, 6, plus 1 times 6 is 6. Then we have 3 times 5, 15, plus 1 times 1, 1. 4 times 2, 8, plus 2 times 6, 12. 4 times 5, 20, plus 2 times 1, 2. So our final answer is 12, 20, 16, 22. All right, so we're moving right along. So what we should also remember, a square is just a times a. Okay, yes. Can I copy down? Because of the time frame we have tonight, I can't copy down, but I'm going to post the video so you could always go back and try it and copy it down and practice on your own, okay? All right, because I really want to get through this whole thing, especially with the transformation. All right, so look at this. I want you to remember even though generally times in is commutative, for matrices, multiplying two matrix is not commutative. And they might have a question that says prove that AB is not equal to BA, or prove or disprove if it's commutative. And you should go in remembering that it is not when it comes to matrices. Everybody with me? All right, so let's do a quick drill. Question number 5. Can I multiply these two matrices? Yes or no? Let me zoom in a little bit. So let's do all, because we should be able to do this quick, right? So the first one, yes or no? Let's do this quickly, guys. Let's go. Yes or no? Can I multiply these two matrices? That's two persons. Yes, these two match. What is the answer going to be? So this is a yes. What the answer is going to be? What is the order of the answer that we're going to get? A 2 by 2, right? A 2 by 2. Very good. Second one, easy to identify. That's a yes. What is the answer going to be, though? That's what I need to know. Excellent. Next one, obviously a yes. Obviously a yes. The fifth one is obviously what? A no. And listen, anytime you get a question like this and you realize you can't multiply, you have to say it, CXC expect you to say, these two matrices cannot be multiplied because the column of the first is not the same as the row of the second. Don't ever just say no. No problem. Everybody with me? Same thing here. These two is a no. You can't. All right. So I hope we are feeling confident when it comes to addition, multiplication, and division. Not division, sorry, because you can't divide in matrices. We know what we're supposed to do when it comes to that. So honestly, when you look at these questions, if any of these come, would you be able to handle it? So for example, I'm just going to make sure I go through the concept. Okay, no problem. So you have to spend some time practicing, because once you understand the steps, you should be good. This means A times B, that's easy. B times A, that's easy. AC. What this means, we always do brackets first. So you multiply A and B first, and then the answer, you multiply by C. Same thing here. Who do you multiply first in E? You multiply B and C first, get an answer, and then you multiply that by A. What does B square mean? B square means simple. B times B, right? And honestly, this here means this. C times A times A. Who you think you're going to multiply first? That's a great question. Who would you multiply first? The A square, right or wrong? Because we remember what BODMAS mean. BODMAS, the O in BODMAS stands for order, and order means power. You always work out the power first. So you would find the answer for this and then multiply it by that. All right? Now, if a question come like this, you know why this should be easy, because this is just about substitution. You know how to multiply two matrices, so ignore this. This is what you would treat with at the end. When you multiply out this, you're going to end up with an answer that looks like this. And suppose when I do that, I get, let's say, 15 here. Or not 15, let's say 14. And then I get here, let's say 12. So when you multiply this, let's say this is the answer you get. Everybody with me? Or let's make it even better. Let's say 12 something. You match it up, minus 7a over 5, 6b. So you realize what? Negative 7a is equal to 14 over 5. Can't you solve this using transposing? So you realize we're back at algebra again. Right or wrong? And the next one, 6b is equal to 12. We just do what? Transpose to find the answer. Again, algebra. And that's why I spent so much time revising algebra, because you need it for everything else. All right, so don't let nothing like this confuse you. They ask you to find P and Q. No, I just made up those numbers. I made up those numbers. I just made up those numbers just to explain the process. You know, I'm not really focused on the actual answer. I'm just making sure you understand what to do. And so what you should do, multiply this, and everybody, you should be able to multiply it by a letter in it. Don't we know how to multiply by a letter? Because of algebra? So we know A times 1 is just A. A times 4 is 4A. Confirm with me if you are with me, please. So you don't panic. You don't let things like this panic. You trust your ability to figure this out. And you know, once one side is equal to another, you solve by transposing. All right. Same thing here. So you see, you got a value for P, you got a value for Q. All right. So let's keep it moving. Let's do a quick check-in. Everybody feeling okay about what we talk about so far? Because we're going through it. I think if we go through matrices tonight, it would give a lot of you a little bit more less anxiety, because a lot of persons express matrices was something they were struggling with. All right, so we're gonna keep it moving. Determinant, extremely important in matrix. So let's move on to determinant. We should know the determinant could be represented by determinant A or 2 lines. This means determinant of A, and this has a formula, AD minus BC, right? And we should know what element is AD and what element is BC, because if you have a square matrix, A, B, C, D. So you see AD is this way and BC is that way, right? Another thing we need to remember when it comes to the determinant, what the word singular and non-singular mean. A matrix is described to be singular if when you find the determinant, the answer is 0. So if they say prove whether a matrix is singular or non-singular, the first thing you do, you set out your formula just like this, and you find it, and if the answer is 0, you say therefore it is singular, or therefore it is not singular, right? Concepts here, easy stuff. So all of these things we should be able to do. I shouldn't have to work with any of this, because we should be able to know. And we can find a value if they say the determinant is 0. So look at this one, for example. I'm going to work out this one because I just want to show you how algebra coming through all the time. They gave us this matrix 8K 4 negative 3. This K can't stress me out because I am strong in algebra. So I know, don't panic. If they say this is singular and they want me to find K, that means that what? The determinant is equal to 0. And if that's equal to 0, I could solve for K. So let me go. What is the determinant of this set? AD minus BC. What 2 numbers am I multiplying? That's 8 times negative 3 minus K times 4. And that is equal to 0. Everybody with me? So far? 8 times negative 3 is negative 24 minus 4K. And that is equal to 0. How do we solve this? We move this where? Over. So we got negative 4K is equal to positive 24. Don't forget, when you move it over, the sign changes. I want K. So I divide by negative 4 on both sides. So K is going to equal to what? Negative 6. Everybody with me? See? We have to learn how to read and understand, and from what they give us, know what to do with it. All right, so we know how to find the determinant. We know how to find the adjoint. Do we remember how to find the adjoint, which we need a lot when it comes to inverse? What do you do to find the adjoint? You switch A and D, and you make B and C negative. That's it. That's the adjoint. Right? So when it comes to that, you switch, you add a negative. And as you see here, if I add a negative to a negative, what is that going to happen? What's going to happen? That's going to become what? A positive. So we need to keep in mind all of these rules. Don't forget your integer rules. All right, so now we're going to go into inverse of a non-singular matrix. Why do you think they're going to have to say it's non-singular? What is the formula for inverse? A inverse is equal to 1 over the determinant of A times the adjoint of A. Anybody remember me teaching you about anything being divided by 0? Anybody remember that? In maths, if you plug this in your calculator, you would realize it would say error or undefined. It just won't give you an answer. But if you put 0 divided by 1, you're going to get 0. The point of this is you cannot divide by nothing. You understand what I'm saying? It is not possible. In maths, it creates a whole deep loophole. So the truth is, why they have to say non-singular? Because if it's singular, it means that this could end up being 1 over 0, and that is impossible. Everybody understand what I'm trying to show you? If you have your calculator next to you, divide 1 by 0, and you will see what I say when it comes to the value of that being undefined. Error. You must get error. Always going to get error because you cannot divide by 0. All right. So inverse A, this is the formula. Everybody good with the formula? And we remember we only apply this portion, the 1 over A at the end. Do we remember that? Do we remember that part? Because why would I apply a fraction to a matrix for it to be harder for me to multiply? All right. So using matrix method to solve simultaneous equations. So we're getting into the real nitty-gritty stuff. But before we continue, this is our halfway mark for matrices. Out of 10, how you feeling about everything I just did? And be honest. Do you remember every single thing I just did? That's a 10. If you remember every single thing. If you remember majority, that's a 8. If you remember half, that's a 5. If you remember less than half, you should know how to rate yourself. So let's go. I need to see everybody ranking, please. Be honest. Don't be afraid. Okay, so let's get into it. Solving simultaneous equations. We should know what simultaneous equations look like because we've done them in algebra. But there's a matrix method to solving, and we have to be able to do so because it's a popular question that comes. So I'm just going to slow down a bit for this section and take it step by step. Now, the notion of this is that, look at this. If I had AX equal B, and I asked you to solve for B, what do we usually do? We usually divide by X on both sides, right or wrong? Because if I want A, I just got to get rid of X. Everybody agree with that? Or let me change it. Let's say I want to get rid of A. So if I want to get rid of A, I divide by A on both sides. And this would cancel, so X would be equal to B over A. In matrices, we can't divide. So what we should remember, we could do another form of division by using the inverse. So for example, 1 over A is the same thing as A inverse. Everybody see that? So going back to the concept of eliminating A, if I want to get rid of A, I simply multiply both sides by the inverse of A. Because if I multiply over here by the inverse of A and multiply here by the inverse of A, what will I end up with? This is going to cancel. So X is equal to A inverse B. That is the concept you need to remember. Look at right here. If this is that, then X is equal to that. Everybody with me so far? Also keeping in mind, it's almost like saying 2 times a half. 2 times a half is 1. 3 times a third is 1. Why? Because these two are the inverse of each other. When you multiply two inverses, you're going to get the identity, and the identity is 1. So when you look at this, that's what it's saying. B inverse times B is the identity. And in matrix, it's not 1, but it's this specific matrix. You must memorize this. 1, 0, 0, 1. That's the identity matrix. I'm going to write it again. 1, 0, 0, 1. The identity matrix. All right. So let's get into an actual question. So what I am going to do is work out an entire question for the purpose of revision. And I hope everybody is able to follow. So let's start off with these two simultaneous equations. Oh, this one is a little hard. Well, it ain't hard, it's just different. All right, can I just start writing out this here, or something need to switch up? Anybody realize anything about this that's throwing you off? Because you have to pick up these things, eh? What is throwing off this equation? First thing first, the x's are correct, but what must be the second thing? The y's. But for the first equation, where's the y? On the wrong side. Where's the constant? On the wrong side. So step 1 would be switching both of them. So that's the first thing you need to do. So 4x minus 5y is equal to -6. Do we agree with this? Is this correct? Is it? Because when I move 5y over, it's going to become negative. When I move plus 6 over, it's going to become negative. So we're good to go. And the second equation is done, sorted out. Plus 2y equals 7. All right. From here, so this is what you expect to start off with. You are expected to write the matrix form of this. Now, be honest. Anybody remember how to do that? So here we see, this is the purpose for tonight, because at the end of the day, you have to be responsible for your own revision, because we've done this before, okay? So you have to be careful about how you're revising. Try to cover as much as you can. All right, so let's go. So first thing first, everybody see the coefficients? What are the coefficients? So you're going to use the coefficients of each term and create one matrix. So we're going to use 4, we're going to use -5. And why do we use -5? Because here it is it's not plus. If it was plus, it would have been positive. Then we got 3, and then we got 2. So the coefficients go in one bracket. We're going to call that A. Who you think going to go in the second bracket? The variables. What are our variables? X and Y. And we're going to call that X. And then we're going to say equal to. And what do you think is going to be equal to? -6 and 7. And we're going to call that equal B. Everybody remember we were seeing that before? That same equation. AX equal to B. Talk to me. So let me just take a moment here and make sure you understand how we got from here to here. What did I select to create A? A is the coefficients of the variables. Everybody see that? B is the variables. What are our variables? X and Y. Now, sorry, X is our variables. B is our constants, -6 and 7. So let me pause here and I need some feedback. Everybody see how I got here now? How did I select my information? How did I translate the equations into matrices? That's 2 yes. All right. Now, what did the question ask us for? Or when we solving, when we are solving, what are we always trying to do when we solve? Isn't solving requiring you to find the variables of X and Y? So you find the values of your variables. Agree or disagree? And the reason I just ask these questions for y'all to stay awake, because I myself, I am falling asleep. I'm tired. So it, like, you know, engagement is helping me stay awake. So I recommend that you try to do the same, right? All right. So that means let's look at this formula first, because this is what's going to guide us. How do I get X? Because X is the letter that represents the variables X and Y. That's what we see. That's what represents it. So we just learn what to do if that's what we need. We got to get rid of the A. How do we get rid of the A? We multiply by A inverse on both sides. Everybody see that? So what's going to happen here? This is going to cancel. So X is equal to A inverse B. Yeah, remember this formula? This is very important. So we use the equation first, but guess what we got to do now? What we got to do now, peoples? We got to apply it to the matrix version, right or wrong? Right? So this equation down here telling us how to find X. What are the two things we got to multiply? A inverse and B. Do we have B already? Yes, we have B already. Who we do not have? We do not have A inverse, and that's where all the work comes in. So before I continue, I need everybody to let me know if they understand the first section of this. Moving from the equation to the matrix formula form. If you got it, say got it. Awesome. Very good. I'll take that. I'll take that. All right. So from here, you follow you follow your steps. When you reach here, you're gonna realize, okay, I need X, and to find X, I need A inverse times B, but I don't have A inverse. So guess what we need to do? We need to find A inverse. And A inverse have a formula. What is A inverse? 1 over the determinant of A times adjoint of A. So let's go. We need to then find two things. We need to find the determinant of A, which is what? AD minus BC. You realize I'm showing all my working, I'm showing all my formulas. So let me zoom out a bit. My foot cramping and my hands cramping. Wow. All right. Let's go. We could do this. So A is 4. So that's 4 times 2. And please just back check everything for me. And then that's minus. And then what is B? B is negative 5 times 3. So let's zoom in now that we have our values. So what we're going to end up with? We're going to end up with 8 plus 15. Everybody see how I get a plus? Be honest. Everybody see how I get a plus? Okay. So what we're going to end up with is what? 23? Yeah. So the determinant is 23. And then, so we got a determinant. Who else we need? We need the adjoint. So the adjoint, and you realize I'm labeling everything. I'm not just going and calculating things like a mad person. I'm labeling everything. So when I'm done, I know where to find the determinant, and I know where to find the adjoint. So the adjoint is going to be what? We got to switch 4 and 2. So 2 go here and 4 go here. And we got to add a negative on both negative 5 and 3. Right? So here we have positive 5 and negative 3. So do I have everything I need to find the inverse now? So my inverse, A inverse, would be 1 over 23 times 2, 5, negative 3, and 4. So let me stop. Do I apply the 1 over 23 yet? Do I do that now? Is that a smart thing, or we leave it like that for now? Because we know what we actually need to do in the long run. We got to leave it like this because at the end of the day, we need to use it to multiply for X. Because X, and then you go back saying, therefore, X is equal to negative, or it's A inverse times B. So you're going to have your A inverse, which is 1 over 23, 2, 5 minus 3, 4 times B. What was our B again? It's negative 6, 7. So yeah, see how much work this is though? You see how much work this is? But is it bringing back everything? Because we did this before, right? Is it bringing it back? All right, so everybody ready? You want me to work it out? Even if you just look to make sure you understand what I'm doing. Yeah, want me to finish work it out? So you just follow. Okay, so let me go. Now, based on this, what did I teach you? I taught you to multiply these two first, get your answer, and then you apply this last. All right, so if I want to multiply these two, what's the general rules? This is a 2 by 2. This is a 2 by 1. So when I look at it, can I multiply them? Yes. And what type of answer will I get? I will get a 2 by 1. So I come down, I map out, my 2 by 1. So 2 by 1 means 2 rows or 1 column. Everybody following me? So next, what do? I know the rule is to multiply rows by columns. So I'm going to circle my rows and circle my columns. And you realize how much columns we have? We only got 1 column. So let's go. We're going to go top and then bottom. So you're going to say 2 times negative 6. Let's write down. 2 times negative 6 plus 5 times 7. Yeah? Then we're going to have negative 3 times negative 6 plus 4 times 7. Somebody with a calculator help me out there because my brain is genuinely off. But I could try a technique. What is 2 times negative 6 is negative 12. Plus 5 times 7 is 35, I think. Yeah. Negative 3 times negative 6 is positive 18. Plus 4 times 7 is 28. Let me know. And this, you know the rules. When the signs are different, you subtract and your answer take the sign of the bigger number. So 35 minus 12 is 23. And 18 plus 28, that's 46. So what is the only thing I'm missing? Don't forget why we're doing all of this. Guess what I forgot, to be honest? Let me see if anybody's seeing what I forget. What did I forget? Look at the first step. What did I forget to do? Excellent. I forgot to bring down the 1 over 23. You have to bring it down all the way down. All the way down. And what else did I forget? X represents XY. Remember from the top? X represents XY. So when you're writing your matrix form, you have to also remember that X is equal to XY. So all of this equal to XY. So guess what I have now? My final stage. XY is equal to, 1 over 23 times 23 and 40. Anybody see how this is so beautiful? Anybody seeing why this is beautiful? So XY is equal to 23 over 23 and 46 over 23. And what is that equal to? 23 over 23 is what? 1. 46 divided by 23 is 2. So what does that mean? What is our answer? X is equal to 1. Y is equal to 2. And just like answering simultaneous, you have to say that X is equal to 1 and Y is equal to 2. So let me scroll back out and go through the whole thing from top to bottom. But in terms of following, are you guys following? Because all of this is not new. So I'm hoping that it refreshing your memory and that it reminding you of all the work you got to do with this question. So I'm going to go from the top. Solve simultaneous equations using matrix. You have to take the simultaneous. What the word is, guys? What the word? Ooh. You have to take the simultaneous equations and represent it in the matrix form. That's what we did here. And the most important part is this AX equal B thing. That's the representation of this format. From the AX equal B, you want to solve. So that means we need to make X the subject. This is the key. This is the plug. This is telling us what we really got to do. We need X, because why do we need X? X represents our X and Y values, right? So from there, it's really a substitution thing, because we have B already from the top. So who do we need to find? We need to find A inverse. So that's what we do. We find A inverse, and that's what we did here. So once we have that, we use the formula to find X. And what the formula tells us to do? Multiply A inverse to B. That's what we did here. And when you come down to the end, your final answer, you put them, you match them up. So you get your X value and your Y value. Everybody feeling better about this? Or remember a little bit now, especially if you didn't remember before? If you're struggling with this, please note again, we have a whole video just going through matrices past paper questions. When you're in your bed lying down, you ain't doing nothing, just watch the video. Something gonna stick, something gonna reconnect. If you do nothing, you can't learn or remember nothing. Okay? Make use of your last days. All right, so that's it for that. Everybody should be able to do that. You should be able to take the video and try it on your own and see if you can get it done. Now, here's the truth. You know, that's the hardest question that could come from matrices. This is the basic matrices question. Is matrix transformation is the hard part. So I'm just going to skim through some past paper questions, not to answer them, but for you to see how the questions come and mentally prepare yourself. So let me know if you are ready to do that. We're not answering not one. We're not answering none. We're just going through the types of questions so that you could connect everything we just talk about with what we're going to be seeing. So again, type ready if you're ready. And we're going to end class here tonight because I don't want to do too much, even though I really wanted to touch on transformation because they literally say come in and we ain't really touch on it much. But that's okay. We're going to figure it out. All right, let's go. So here we see the matrix M has these values. And what is the first thing you realize? One of them has what? A letter, a variable. And look at what it says. Determine the value of P for which M is what? Singular. What does singular mean again? Singular mean that the determinant of M is equal to 0. What is the determinant of M? AD minus BC. So what do? You multiply and substitute and you make this equal to 0 and then you solve for P. Everybody with me? We did an example like this before. We know a singular mean, we know what to do. Even if it's a letter, we know how to solve. All right, let's go. Another one. Here you see they give us 2 by 2s and they're going to ask you to find 2a plus 2b. So you know what to do. You multiply a by 2 first. Every digit inside you multiply by 2. And that answer, you add it to b. So we should be good here, right? I need her to answer every time I ask her. Y'all need to tell me that you're good. If you're not good, you need to tell me you're not good. I might rough you up a little bit because I'm a little cranky, but I got you still. Okay, I got you. All right. Next one. Determine B inverse. What I like about this, you know what I like about this? You realize they asked you to find B inverse by itself first. So, you know, ain't overwhelming in one question. Because if you look at the next question, they say no one with AX equal B. But guess what? Guess what makes this a little confusing. Anybody realize what makes this a little confusing? Even though we're using B, the matrix B, in this equation, you realize B is really A? Let me see if you understand what I'm trying to show you. Look at it. You know, we got our general formula AX is equal to B. But look at it. This B is actually this A. I hope I see what I'm showing you. You seen it? Be honest. So this would have confused students, but you have to think. They just use this as two random names of matrices, but you know you got a general formula. So what would you do with this here? You don't find B inverse. We know that X is equal to A inverse times B. In this case, it would be really B inverse here. So everything we just did just now is this exact same question where you find. Guess what? The only thing they didn't give you is the simultaneous equation. But you realize it's the same thing. They're saying the same thing we just do. Come on, talk to me and let me know if you've seen it. Because that's students' problem. They don't see these things. All right, I'm moving on. So next year, they say calculate AB. That's easy. We should be able to knock out that. Look at the next question. Show that the matrix product is not commutative. What do you do to show that? You don't find AB. So who you should find next? Good night. Who should you find next? Look at what they ask you to prove that it's not commutative. You just find AB. Look at here. To show that it's not commutative, you must prove that AB is not equal to BA. So who do you need to find next? You done find this already in one. That's what you did here. So all you need to do is calculate BA and then put it side by side and show that they're not equal. Hello. Let me know if you see what I'm showing you. We spoke about this earlier tonight, proving that something is commutative or not. And it obviously is not, because I tell you to remember that it is not, never, multiplying matrices is never commutative. So it could come and look at here, right, just like how we talk about it. Next, find A inverse. We know the formula, 1 over the determinant of A times the adjoint of A. We did this, so everybody should be able to handle this and mash this up. Next one, given that this, M is equal to this, calculate X for which M is what? You see, they're just changing it. Rather than saying the word singular, they tell you that the determinant is equal to 0. In the same exact question that come in the year before that we just see in a different way. Moving on. Write the following simultaneous equations in the form. Look at here again. You get 1 mark. Y'all want me to do it out quickly again? How do I write it out in AX equal B form? Who represents the A? The coefficients. So A would be 3, 2, 5, 4. Who is X again? Who represents X? Anybody remember? It's going to be X and Y. Remember, X represents the variables. And then B, who is B? B would be who? These terms right here, -1 and 6. You realize it's the same thing coming again? Look at here. They're in the same thing. You realize it coming in different ways. And that's why students struggle. They are unable to see the same thing they learn already when they come in a different way. And that's what I want to focus on right here, right now. And look at what they ask us to do. Solve for X and Y. Ain't the same thing we're doing all night. Let me go back to the steps. Look at here. That ain't the same thing we did here. They just did half of the work for us. So we know we got to find X by finding A inverse times B. And we need to find A inverse first and then multiply and then equate the two sides and make sure they balance off. Okay. If you need to watch over the video, okay? Because it's the same thing coming over and over again. Watch this now. The matrix M is defined as this. Determine the value of P for which the matrix does not have an inverse. If it does not have an inverse, what did we learn about that? Remember, we spoke about that. There's a certain number that doesn't have an inverse. Who don't have an inverse? Any number that is singular do not have an inverse. Everybody remember why? If your determinant is equal to 0, what's going to happen when you're finding the inverse? So let's look at A inverse. 1 over the determinant of A times the adjoint of A. Can you find anything if this is 0? Nobody ain't answering. But I can still talk, okay? All right. We're going to go through one more and that's it. All right. This ain't the same question coming. Anybody picking up the pattern? Anybody realizing the question coming like the same over and over? Because if you look here, what we have here ain't the same thing with the simultaneous equations. Look at that. Same exact thing. AX equal B. So you don't know what you got to do. X is equal to A inverse times B. You find A inverse, you multiply it, and you find X and you find Y. Same exact thing we do in the whole entire time. All right, let's just take a few. Determine inverse, that's easy. The matrix T maps, blah, 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 determines the value. Okay, this is the part we don't really know, the transformations. That's what we're going to do tomorrow morning. I'll let you know. If I have one person, I'm going to work with one person. If I got 2, I'm going to work with 2. If I have 0, I can't do nothing. So I'm going to start probably at 11 a.m. So I'm only going to focus for the first hour on matrix transformation because that is what is coming for sure. It is coming for sure. And we have not done any practice with it at all. We've done transformations in geometry, like the reflection, the rotation, the translation, and the shrinking and enlargement, but we did not do any matrix transformation. So that question coming, if you really want to master it, if you're trying to aim for a 1 and a strong 1, I recommend you attend that class, okay? All right, so that's it for tonight. So we done matrices. You see, we're doing vectors tomorrow as well. We actually went through everything possible that could come on the matrices. That's what we just did. That's it. That's the end of that. So yeah, how y'all feeling now that we went through everything on the matrices? Because it can't get no harder or easier than that. The hardest questions is a simultaneous equation question. So out of 10, rate how you're feeling based on the session we had. And then I'm gonna post it right now. I'm not gonna go to sleep until I post it. It'll take a while to upload, but I'm gonna stay up until it uploads so y'all can have it as soon as you need it in the morning. Okay. We're focusing on the weaker areas. So just a heads up, tomorrow, another common topic people mentioned was vectors. So vectors gonna be done. Measurement was another one that a lot of people mentioned that they were weak in. So I'm gonna focus on measurements as well. And please note, you don't need me, you know. You still have your tech. You see that textbook, the CXC tech book, that's scenario on PDF. If you really go through it, you'll realize everything we're doing right now. You can't hear me? Everything that we're doing now is in it. You can literally just read that from the front to the back and it's gonna be so useful. Please be proactive. We have a few days, or you want to touch volume, we're gonna practice some CXC measurement questions tomorrow. We're going hard on it for at least an hour, and then we're gonna take a break and we're gonna do some other topics. Okay, everybody okay with that? Please note that I had, after they changed the exam, I haven't been able to have class because I canceled classes during April. That's why we were having classes every day. And I made schedules to make up for the canceling for a month. in me. So I had to have classes with my first to fourth farmers. So that's why I couldn't have class every single time because they were my main priority because I planned for the original date of the exam and not this one. Okay. So don't feel like I just not studying RU. It's just that parents been concerned about, getting time too. So I had to kind of shift my energy towards them. But I canceling class on Monday with them and I canceling class on Tuesday with them. Okay, yeah, I have first to fourth farmers. So I letting y'all know Monday, I might even stay home on Tuesday. So if anybody's staying home on Tuesday after English, if you're doing English, I would be available for help. Private students, if you need me, you have me all day Tuesday as well, okay? So if you need me, that's the day for me to just do whatever. All right, so that's it for tonight. See you tomorrow. Get some rest, stay hydrated, stay positive, all right? So see y'all tomorrow. Bye.